right, let's put together our two independent means and our paired data. And let's talk about the language and the wording that we use to describe what those things are and those results. Okay, so first of all, um, these are two different phrases that sound very similar. The difference of averages. Okay, so hone in on the fact that here I have two separate averages, and I'm talking about taking the difference between those. So, first, you are getting the averages, and then you find the difference between them and see if there is a significant difference between those two averages. All right, but then with paired data, we have this average of the differences. And that was a situation where we would first find out what all of those differences are in the paired data. Remember, we paired them because they had similar qualities and we were reducing all that variability between the subjects. Okay, so this is an example of a before and an after, or twins that you put. Even the woman and the man that had um, the same type of model of car, they were then twinned by that type of model of car. All right. And so we were finding the difference first. And then we got one average of that list of differences. All right, so keeping that in mind. So I want you to kind of look through these situations, and we just want to then talk about what we would call those and then what test we would run. So for each problem, we'll circle if we are doing a hypothesis test for two separate means, or if it's a hypothesis test for matched pairs. Okay, and then of course, using the correct language that goes with that. Is it the difference of the two averages, or is it the one average of the differences? Okay, so read that first question to yourself, and let's see how you do on that. Okay, so I see that these would be two separate independent groups of subjects. And so because that was two separate independent groups, I would get two separate independent means. So I'm going to have difference of two separate averages. So I'll have a hypothesis test for two means. All right, read the next one to yourself. Let's see how you do. Does right-handed, I'll go ahead and read it, right or left-handedness affect how fast people type? Random samples of students from a typing class are given a typing speed test in words per minute, and the results are compared. Significance level is at 0.10. All right, because you are looking for a difference between the groups in either direction, right-handed faster than left or vice versa, this is a two-tailed test. So our HA would be a not equal to. But how many samples would we have, and would they be paired or matched is the question. Well, I hope you see that they would have to be two independent groups of students, because um, you can't, in fact, this would even be a study because you are not randomly assigning students to be a certain handedness. So you would be looking at a subset of subjects, and then you would be sorting them by their trait and then doing that there. So we have a hypothesis test for two independent means. And so, of course, that is the difference between two averages. So the reason I'm pointing this language out to you is because this plays into kind of how you talk about your um, your conclusion, the language you use in your conclusion. For example, with the paired data, it really is important that you are stressing that we're talking about the average of the differences. Okay. With the two different means, the two separate independent means, the language of your conclusion typically works itself out and makes that clear. But I'm pointing this out because most often the language in the conclusion for matched pairs is often unclear. And so I wanted to make sure that in your language for your conclusion for matched pairs, you were talking about the average of the differences between the subjects. Okay, the average of the differences between the treatments or the events or whatever it was that had happened among the paired data. Okay, here was a farmer. He has the heights of each stalk. He gives them fertilizer, and then he measures the same stalk. So of course, we are measuring the difference between the same stalks. Okay, uh, maybe we're doing that because where they are located might have an impact on their growth rate, the type of soil or amount of sun, whatever. So we can control all those variables by pairing them. Alrighty then, here we have this one. Random sample of 10 students. And of course, here we have a before and after. This is one set of students. So of course, we're interested in those differences and we'll have an average of the differences. All right, on this next one, we have body temperature and then gender and heart rate. And so we are categorizing with the gender and then getting each of person's heart rate. Is there a significant difference between the average body temperature for men and women? So here we have two separate independent groups. So hypothesis test, and we would be finding the difference between those two averages. And finally, we have this situation where it's the manager's salaries before and after undertaking the PhD. So, wherever these people are working, wherever these managers are, we look at their salary before and then they get their PhD and we look at it after and see what difference is made then. And so, of course, that would be paired data because it's the same managers before and after the PhD. All right. So, just wanted to bring this information to the forefront of your mind, make it a conscious understanding of the language that you will use when you are stating your conclusions. Now you'll be working on your warm up for this Unit 8 quiz, and the warm up will include one means, two independent means, and matched pairs. And then if you're going to be given a hypothesis test or a confidence interval, you'll need to know which one of those you are doing for them. All right. So good luck to you on your warm up, and I hope that you're able to kind of put all this information together.